Hello students, let us continue the session on surface area volume. In the previous session, we had discussed and completed exercise 13.1. Let us continue with exercise 13.2. First question here is, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter. The height of the cone is equal to its radius. This information is very important. Find the volume of the solid in terms of pi. So we need not substitute the value of pi as 22/7. You have to solve in terms of pi. This will be the corresponding diagram. 1 centimeter is the radius of cone and hemisphere. They have given that the height of the cone is equal to the radius, so the height of the cone is also 1 centimeter. Let me mention that height of conical part equal to radius of conical part, and both are equal to 1 centimeter. The radius of conical part is same as the radius of hemispherical part. And that is equal to 1 centimeter. Therefore, to look at this complete figure, it's a solid combination of a conical part and a hemispherical part. So the volume of solid will be equal to volume of conical part plus volume of hemispherical part. Volume of the conical part is 1/3 pi r square h plus the volume of hemispherical part is 2/3 pi r cube. So we need to substitute r as 1 and h as 1. Therefore we get 1/3 pi times 1 square multiplied to 1 plus 2/3 pi times 1 cube. So we get it as 1/3 pi plus 2/3 pi. On the addition, we get it as pi centimeter cube. Second question. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its ends by using thin aluminum sheet. The diameter of the model is 3 centimeter and its length is 12 centimeter. If each cone has a height of 2 centimeter, find the volume of the air conditioned in the model that Rachel made. Assume the outer and the inner dimension of the model is nearly the same. This would be the figure. The diameter of the model is 3 centimeter. Total length of the model is 12 centimeter. The height of cone is 2 centimeter. So to get the height of the cylinder, I need to subtract this cone height and this cone height. Totally 4 centimeter to be subtracted from 12 centimeter. We will get it as 8 centimeter. Let me write the height of the conical part. The height of the conical part, let me represent it with h1, which is 2 centimeter. the radius of conical part will be same as the radius of cylindrical part. I'll consider both to be r. This is equal to 3 by 2 centimeter because 3 centimeters is the diameter, and the height of cylindrical part will be equal to 12 minus 2 plus 2, which is 8 centimeter. So I need to find out the volume of the air conditioned in the model. So it's a volume which is equal to volume of the air contained. It's not conditioned, it is contained. This will be volume of the cylindrical part plus 2 times the volume of conical part. Volume of the cylindrical part is pi r square h2. This height I'll consider it as h2 plus 2 times volume of the conical part is 1 by 3 pi r square h1. Let's substitute pi times 3 by 2 whole square into height is 8 plus 2 times 1 by 3 pi r square, right? This is r square. So pi times 3 by 2 whole square multiplied to 2. We will simplify this. 3 by 2 whole square is 9 by 4. 4 2 times, so 18 pi plus 3 by 2 whole square is 9 by 4. 2 times, 3 will get cancelled. We will be getting 3 pi because this 2 and the denominator 2 will go cancelled. This will be equal to 21 times pi, which is equal to 21 multiplied to 22 upon 7. 7 3 times, so we will get 66 centimeter cube. So the volume of the air contained in the model is 66 centimeter cube. Question 3. A gulab jamun contains sugar syrup up about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with 2 hemispherical ends, with each length 5 centimeter and diameter 2.8 centimeter. So basically the jamun is shaped like a cylinder. At the ends there are 2 hemispheres. It would look like this. The length of the jamun is 5 centimeter and the diameter is 2.8 centimeter. So for the hemisphere, its radius will become half of 2.8, which is 1.4 centimeter. From the length, if you subtract 5 minus 2 times 1.4, we'll be getting 2.2 centimeter, which is the height of the cylinder. So let me mention certain things here. The radius of hemisphere will be equal to radius of cylindrical part. This will be half of 2.8. This will become 1.4 centimeter. Hence, the height of the cylindrical part will be equal to 5 minus 2 times of 1.4, which is 2.2 centimeter. So let me find out the volume of one gulab jamun. This will be equal to volume of cylindrical part plus twice the volume of hemispherical part. Volume of the cylindrical part is pi r square h plus volume of 2 times the volume of hemispherical part, pi r cube. 2 by 3 pi r cube is the volume of hemispherical part. Let us substitute the value. It's pi times 1.4 whole square multiplied to 2.2 plus 2 times of 2 by 3 times pi multiplied to r cube is 1.4 whole cube. Let us take the value of pi as 22 by 7. So 22 by 7 into 1.4 into 1.4 into 2.2 plus 4 by 3 times 22 by 7 multiplied to 1.4 into 1.4 into 1.4. On simplifying, we get 13.552 plus 11.498. This is equal to 25.05 centimeter cube. This is the volume of one gulab jamun. Now the question is, we need to find for 45 gulab jamuns. So volume of 45 gulab jamuns this will be equal to 45 times of 25.05, which is 1127.25 centimeter cube. Now we can find out the volume of sugar syrup. Volume of the sugar syrup is 30% of volume of 45 gulab jamuns. %30 means 30 upon 100 multiplied to volume of 45 gulab jamuns. We get it as approximately 338.17 centimeter cube. Question number 4. A pen stand made of wood is in the shape of cuboid with 4 conical depressions to hold the pens. The dimensions of cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. Radius of each depression is 0.5 centimeter and the depth is 1.4 centimeter. Find the volume of wood in the entire stand. The conical depression would look like this. For the conical depression, we have got the depth, which is equal to height, which is 1.4 centimeter, and the radius is 0.5 centimeter. So the volume of entire stand will be volume of the cuboid minus there are 4 conical depressions, so 4 times the volume of depression. So let me mention that volume of wood in entire stand will be equal to volume of cuboid minus 4 times volume of conical depression. Volume of the cuboid is LBH minus 4 times the volume of cone is pi r square h. 4 by 3 pi r square h it becomes, right? Length is 15, breadth is 10, height is 3.5 minus 4 by 3 times. The value of pi I take as 22.7 multiplied to the radius is 0.5. I'll better write it as 1 by 2. Height is 1.4. This should be simplified. Here 7 0.2 times 2 multiplied will get cancelled along with 4. So we get 22 into 0.2 upon 3. On multiplying this, we will get 525 minus 1.47 roughly. It becomes 523.53 centimeter cube. Question number 5. A vessel is in the shape of an inverted cone. Its height is 8 centimeter. Radius of the top is 5 centimeter, which is open. It has to be filled with water up to its brim when lead shards, each of which spear of radius 0.5 centimeter are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shards dropped in the vessel. For the conical part, it would look like this one. The radius is given as 5 centimeter and the height of the conical part is 8 centimeter. They have given the radius of the lead shards, so we can find volume of the lead shards, which is spherical, and volume of conical vessel. So let me mention the height of the vessel. Height of vessel, I'll write it as small letter h, which is 8 centimeter. Radius of the vessel, I'll write it as R1, which is 5 centimeter. And the radius of lead shard, I'll write it as R2, which is equal to 0.5 centimeter. As per the question, volume of water flows out will be equal to the number of lead shards multiplied to the volume of one lead shard. So volume of the conical flask, conical vessel, 1/4 has come out. So one fourth of the volume of conical vessel will be equal to the number of lead shots into the volume of one lead shot. So it is 1/4 of volume of the conical vessel is 1/3 pi multiplied to radius I have taken as r1, so r1 square multiplied to h, which is equal to n times of volume of the lead sphere is 4/3 pi r cube. I have to write pi r2 cube since I have taken the radius as r2. Here we get this particular thing as 12. This 12 has to be cross multiplied. It becomes 12 into 4/3, 4 times, so we get 16 times of n multiplied to r2 cube. Here pi r1 square h. If you observe, both sides pi will get cancelled, so I need not write this pi. This implies that n will be equal to radius r1 square means 5 square, multiply the height 8 divided by 16 times of r2 cube is 0.5 whole cube. If you calculate, you will be getting 100. Therefore, 100 lead shots dropped into the vessel to get 1/4 of the volume of the conical flask or conical vessel. Question number 6. A solid iron pole consists of a cylinder of height 220 cm, the base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and the radius 8 cm. Find the mass of the pole if 1 cm cube of iron has got approximately 8 gram mass. They have mentioned use pi equal to 3.14. There is one bigger cylinder. On that there is a smaller cylinder. It would look like this. The radius of the larger cylinder is 24 centimeter. Sorry, the diameter is 24, hence the radius will be 12 centimeter. I'll consider this as R1, and the radius of the smaller cylinder I'll take it as R2. The height of the larger cylinder I'll take it as H1. The height of the smaller cylinder I'll take it as H2. So on observation, it's very easy that you can identify volume has volume of this larger plus volume of the smaller cylinders. So volume of pole will be equal to volume of larger cylinder plus volume of smaller cylinder. Volume of the larger cylinder is pi r1 square h1 plus volume of smaller will be pi r2 square h2. Let's simplify. Pi times 12 square multiplied to 220 plus pi times r2 square is 8 square times 60. So we get pi times 144 multiplied to 220 plus I have taken pi as common plus 8 square is 64 has to be multiplied with 60. We get it as 3.14 we multiply 2. On simplifying this part which is there in the bracket, we get 35520. On multiplying, we get 11532.8 centimeter cube. They have given that mass of 1 centimeter cube of iron has got 8 gram. Therefore, mass of 11532.8 centimeter cube of iron will be having 1152532.8 into 8. This will be, so approximately we would get it as 892.262 kg. Question number 7. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in the right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder. If the radius of the cylinder is 60 cm and the height is 160 cm. Here the height of the cylinder is 180 cm together, and the height of the sphere or the radius of the sphere is 60, so the height of the cone is 120 cm. So let me mention that radius of hemispherical part equal to radius of conical part. This will be equal to radius of cylindrical part, and all the three will be equal to 60 cm. Let me call the height of the cylinder as h1, height of cylindrical part is 180, which is, I'll call it as h1, and the height of conical part, I'll call it as h2, is 120 centimeter. So the volume of water left in the cylinder will be equal to volume of cylinder minus the sum of the volume of sphere, that is hemisphere, plus the volume of cone. Volume of a cylinder is given by pi r square h, here h1, minus volume of hemisphere is 2 by 3 pi r cube, plus volume of cone is 1 by 3 pi r square h2. Substitute the values, we get it as pi times 60 square multiplied to 180 minus the sum of 2 by 3 pi into 60 cube plus 1 by 3 pi 60 square into 120. Let's further substitute. We get pi times of 60 square as common. We get it as 180 minus 40 plus 40. So we get it as 22 upon 7 into 60 square is 60 into 60, and 180 minus 80 is 100. We get 1.131 meter cube. converted the centimeter cube in terms of meter cube, and the final result is 1.131 meter cube. Question number 8 is the last question of the exercise. A spherical glass vessel has a cylindrical neck 8 cm long, 2 cm diameter, and diameter of the spherical part is 8.5 cm. By measuring the amount of water it holds, a child finds that the volume will be 345 cm cube. Check whether she is correct. Taking the above as the inside measurements and pi value as 3.14. This will be the spherical glass vessel which is having a cylindrical neck. The length of the cylindrical neck is 8 cm, that's the height of the cylinder. Radius of the cylindrical part, I will call this as R2, this will be equal to 1 cm, and the radius of the spherical shape is 4.25 cm. Here, the volume of vessel will be equal to volume of spherical part plus the volume of cylindrical part. Volume of the spherical part is 4 by 3 pi r1 cube plus pi r2 square into h. We get it as 4 by 3 pi times the radius is 4.25 whole cube plus pi times r2 square is 1 square into h is 8. Therefore, we get it as 4 by 3 into 22 upon 7 into 4.25 into 4.25 plus 22 upon 7 into 8. Sorry, they have given pi value should be taken as 3.14, so 22 by 7 will not work. Let's take it as 3.14. So we get approximately 346.51 centimeter cube. So our answer is incorrect because this volume is slightly larger than the volume which is mentioned here. That's all for today's session. Thank you.